This is 2.8, Composition of Functions, Part 2. We're going to start with a warm-up on finding domain. See if you can hit pause and give that a try. We talked about it last time. And come back and check your answer. When we're finding the domain of a rational, we want to know all the numbers that are okay to substitute in for x. But sometimes it's easier for us to work backwards. So working backwards tells us that we can't have 0 in the denominator. So this 9x squared cannot be 0. We don't care about the numerator at all. So if we solve, we get x squared can't be 0 after we divide both sides by 9. Take the square root, and x still can't be 0. So when we do the domain, we want all numbers except for 0. Okay. Now today we're going to be still working with compositions of functions, same functions that we used before, but instead of just adding, subtracting, multiplying, and dividing like we did before, we're going to do what is called a composition. So this little symbol here, that open circle, that is the symbol for composition. What it means is you take the second function and you put the second function in the first function. So another way to write it, sometimes they have h of g of x, so it looks like the g of x is inside the h of x. So we're going to take g of x here, this whole function, and we're going to put it into h of x, so into the x portion of h of x. So it'll look like this. We'll start with the 4, but then instead of the x, we're going to put in all of g of x, 3x squared minus 2x, and then we still have the plus 7 on the outside. And then we need to simplify. So distributing the 4, we get 12x squared minus 8x plus 7. Okay, then as far as domains go, because we're going to be talking about domains, this is a quadratic. Quadratics have the domain negative infinity to infinity. Let's try another one. So take a look at number 7. See if you can figure out which function is supposed to go inside of the other function. Hit pause, give it a try, and then come back and check. So we should be putting g of x into f on this one. So that means we're going to start with f. F is x squared, so that means we're going to take g of x and square it. 3x squared minus 2x squared plus 6. Now, if you didn't write all the functions down from the previous page, go back and write them all down so you know where this came from. All right, to square, squaring means multiplying by yourself. So we are going to take 3x squared and multiply it by itself. 3x squared minus 2x times 3x squared minus 2x plus 6. We're going to multiply all that out. Get 9x to the 4th minus 12x cubed plus 4x squared plus 6. None of those are like terms to combine together. So this is a quartic function which behaves like a quadratic, so it'll look something like that if you graph it, which means it has a domain also similar to a quadratic of negative infinity to infinity. All right, please try g of f of x. And again, if you forgot the functions, zip back and find those. I can even write them here for you. F of x is x squared plus 6. And g of x is 3x squared minus 2x. So this time we should be putting f into g. So it's the opposite of what we did on number 7. 7, we put g into f. Now we're putting f into g. And you'll see we get a very different answer. So you cannot switch them around. All right, so if we're going to put f into g, that means we're going to take this whole f function here and put it into g, but g has two x's, so we have to put it in for both of those x's. So we have 3 times x squared plus 6 squared minus 2 times x squared plus 6. Again, this one is being squared. Just like we talked about last time, squaring means multiplying it by itself. So we have to take x squared plus 6 and write it out twice. Meanwhile, we can distribute this negative 2 to negative 2x squared minus 12. And then we need to do a lot of simplifying here. So we need to multiply those together. Keep that 3 on the outside. We have x to the 4th plus 6x squared plus another 6x squared plus 36. We still have the minus 2x minus 12 out there. Then we want to distribute the 3x to the 4th plus, if we add those together, because those are like terms, that would be 12x squared times 3, so 36x squared. Plus 3 times 36 is 108, minus 2x squared minus 12. And we still have some like terms we need to combine together there. 3x to the 4th. Combine our x squareds, we get plus 34 x squared, and combine those constants to get plus 96. This is a quartic like we had before, so it has a domain of negative infinity to infinity.